Hey guys, let's get this party started, and today another FNIRSI novelty arrives to the TechCornerTV workbench. I have a few multimeters here to review, and I don't know why they are always being left behind, but today that's not the case. This box has what I think it is the first FNIRSI multimeter. It's the S1 and it's a smart multimeter. FNIRSI is increasing the range of their products. We will see this year some new items other than oscilloscopes or components testers, and this S1 multimeter follows that trend. For disclosure, this item was sent for review with no costs for me. Let me thank FNIRSI for their collaboration, but let me also thank my viewers that continuously have been using the channel affiliate links on the screen and also product affiliate links in the description to help me support the channel. Since after you use these links and for a short period, I receive a small commission for your purchases on AliExpress and Amazon. So thank you so much for sponsoring the channel even without paying a cent more on your purchases. Enough to chat, let me show you the feature highlights of the S1 multimeter. Let's do this. So we are in that point of the video where I will show you what comes in the box. Let me just take this plastic, everything out. We have this retail box, the usual FNIRSI retail box. I think I saw on AliExpress or on YouTube or something like that this model in yellow, but must be some pilot or something because I didn't see on sale. We still have, as always, here in English the features and specifications. Yeah, looks good. Okay, so let's see what we have in here. Okay, we have here the multimeter. Let's wait a bit. And what else is in the box? We have a set of lids. Yeah. It seems to be plastic, but it's flexible. I will show you in a bit. What else? We have in here the cable, USB Type-C to USB Type-A, very nice, and the normal quality control cards, and also the manual. Let's start with the manual. Okay, we have English, Chinese in the manual. Yeah, this is the new format from FNIRSI. It seems okay, a lot of instructions. Yeah, okay, so user manual, we have the cable and the lids. Let's see the lids. Yeah, this is not the best lids, but yeah, this is plastic, it's not silicone, but even so, yeah, they are cheap lids, but very pointy. Yeah, this is very good to use on breadboards, on small things. Okay, and let's see how is the multimeter. Let me just open this small bag. Okay. So in terms of first impressions, it seems pretty easy to use. It's very compact. It is well finished. We don't have any sleeping area in here. It's all plastic. Yeah, and okay, we have a LED here, like a lantern. Also the power button and the USB Type-C socket for charging, and both sockets for the inputs. 3 buttons, pretty simple to use. If you are wondering why I don't take this off, is because it helps me to record this better without so much reflection. And yeah, let's power on and see what we get. The letters are fantastic. we have a very good letters, big. Yeah, it seems very nice in terms of readability. We only have 3 buttons, so in here we have the, I think, the power detection. This is also related to the power detection, and we have a hold button to hold the signal, and you can power the lantern like this, yeah, and to shut it down, press it again. So yeah, seems very nice. Let's test this and see what we get. We have the auto mode, and you can select also manually what you want to test, like this. Okay, we have temperature also. Okay, temperature, Fahrenheit and Celsius, and back to normal. Okay, let's start the testing. So the first test that I will do is the voltage test. I have here a reference voltage generator. It will generate 2.5 volts, 5 volts, 7.5 volts and 10 volts. This is a reference signal generator, a voltage generator, so it will have a stable signal to be analyzed by the multimeters. So in the top right corner you should have my Siglent multimeter. This is the multimeter that I trust most. And okay, let's start. I have here my Unity 61E. It's an awesome oscilloscope, and obviously the S1 here. I will now power on the okay. So the first signal that we have, let's put this in 2.5 volts. So in the 2.5 voltage range we have 2.484 in the S1, 293 in the Unity, and 498.99 if you round the number in the Siglent. Pretty much near the 2.5 volts in here. Let's move on. We have now 5 volts. It's pretty much on the mush in the Siglent. We have 4.9923 in the Unity and 4.966 also in the S1. Okay, it's acceptable. I have to see what is the error range of this one. Now we are with the 7.5 volts. Siglent has 7.498, really near the target. Unity has 7.487, and this one has 444. So this one is always reporting a bit low than the other two, but even so it's near the target. And okay, so the last one we have 10 volts precisely on Siglent. You could not even a millivolt on the side. We have 986 volts, 9 volts, 0.986 millivolts in the Unity, and 9.926 volts on the S1. Okay, I think this is pretty near also from the target. It's not so precise as the other two, but it's also much cheaper. And yeah, for voltage that's it. I will now power my millivolt test board to see how it handles the millivolts. Okay, I have here already my millivoltage board, but we will not be able to test much. If you see here, we have a limit of 0.75 voltage DC, the lowest limit that it will detect. So yeah, we will test the 500, the 1 volt and over also in this board to see what we get. In terms of precision, we were working with 0.8% reading plus 3 digits. So the values that we have, I think they are mostly between this error range. So let's see what happens when I connect this to my millivolt test board. Obviously, let's put this in millivolts. Obviously, the first ones are not even detected. He detects only resistance, as you can see. Yeah, nothing happens here. Oops. 500 millivolts he doesn't detect. We are at, I think, 100 millivolts, and this is normal. It's on the manual, so we don't even have to worry about this. What should detect is this one. It's 1 volt. Let's see what we get here. I have to change this one. So in 1 volt we have 0.986. It's more or less what we have on Unity and also on Siglent. Well, a few digits to the side, but nothing special. This is 2.5 volts. In 2.5 volts he detects 474, 483 in this one, and 488 on the Siglent. So also good. And the last one, it's 5 volts. Let me connect here and see. Okay, in 5 volts we have 4 volts 888, 4 volts 920 on Siglent, on Unity, and 4 volts 926 on 27 on Siglent. So yeah, with these boards it seems also good. So in this next test I will see how is the accuracy of the capacitor reading, measuring of this device. Let's start. I have here a reference board for capacitance. We have 1 microfarad, 10 and 100 and 1000 microfarads increase switches. So let's start with 1 microfarad. Let's see what we get here. Okay, 1.04. It seems good. Let's try with 10 microfarads. Okay, it's reading 0.983. So we have 9.83. No, not bad also. This is a capacitor, so there is always some oscillation. We have 100 microfarads. Let's wait. 98.25. Okay. Let's see what we have in here in the last one. Okay, it takes a bit to read, but 100 to the 0, a little change. Yeah, 100 microfarads, very nice. So what we'll have in this one, it's also 198. So it should, let's do a 200. Okay, it's getting there. 198.9. That's normal, since this first one, this capacitor, will not give you 100 precisely. The second one does. Yeah, let's see what we have here. 200 to the point. Yeah, very nice. So this first capacitor, it's not exactly 100. Okay, let's try 1000 microfarads. It's reading, yeah, 953, 55, a bit far. Let's try to the last one also. 985 also. So yeah, I think those are not exactly to the point. We should have 200. Yeah, 2000, 1.940, and yeah, so I think it's okay. Let's try 10 microfarads again, but activating other capacitor. 10.77, 75. Okay, I think it's okay. So moving on, let's see some resistance. So now let's see how this handles with resistance. I have a 8-decade programmer resistor board here. It can go from 0.1 ohms, I believe, to 1 mega ohm. So yeah, one thing that we have to understand is that even this has the ability to, let me connect this, it will start beeping because I am with everyone at 0. Even he can detect, for example, 1 ohm, 0.01 ohm. It's not quite okay, but it's there. Let me go to here, 0.10. Yeah. So he will not, let me take this out. He will detect this kind of resistance as a continuity, and that it's not so cool. I think that he will start detecting the resistance from the, let me see here, the manual, from the 50 ohms. And for me, that's quite high value for that. Yeah. Yeah, he says it has 0.1 ohm, but in reality, he will detect this as continuity. So yeah, there is also an issue that might be my problem, but while going through select, this is the continuity. Let me put here something. Yeah, it detects, but he always consider this continuity, and that only stops, let me see, 50. This should be enough. Yeah, 59 ohms, and it will stop. So yeah, it's a pretty high value for not beeping. So we should have continuity in one function and the resistance in another function. Right now I'm not in auto mode, I'm in selection mode, like this. In auto, I understand that it might have some issues. 60 ohms, let me see. But when selected is this one, I think. When selecting the manual mode, it should be able to detect lesser values without continuity. So let's try here in the end. This should be 100 ohms. It's detecting 90, and the other one 80. Maybe this is 90. Let me take this. Yeah, it is 90. So it's okay. 91. It has a little overshoot. Okay, so this one should be 100 ohms, and this one should be 900 ohms. 0.k. Okay, it's the same. So let's try 1k now. Let me put this here, and 1k. 999, it's pretty damn near, and 90k, 9k, sorry, 899. Okay, so it seems to be pretty near. This one should be 10K, I believe. Yeah. And 90K. Whoa, this is on the spot. Very nice. Let's go directly to 1 mega. Yeah, okay. And 9 mega ohms. Okay, it seems accurate. Let me try here directly with a resistance. What we have here. So this is 680K. That's exactly what it is. Awesome. Okay, it seems okay. Let's move on to the temperature. For temperature measuring, the multimeter comes with this probe. Yeah, it's a temperature sensor. I have to cut here this. Okay, here we have it. Let's connect this to common and the other one to line. Okay, select temperature. Auto. So in terms of temperature, the room temperature seems to be 21 degrees. I have here another thermometer that says that is 90. I believe more in this one. What I will do is connect my finger to both sensors and see what temperature they will give. Okay, 26, 26, 27. To be honest, I trust more in this than this one. But let's see. This is using the Type K sensor. Let me move from to this side to take the hand off the way. Yeah, but the body temperature is around 35, 36 degrees, more or less, 37, it depends, but 36 is the reference. So this should be near that value, since the thing I have my hands right now a bit cold. Yeah, but 28, 27.5, I think that we can trust in this reading. One of the features that this has, and we have several buttons in here, let me put this in auto, is the lantern. It has a small light, you just press hold for a while, and you have a light here that will allow you to illuminate some of the darker places, like a breaker box or anything like that. And to take this off, just press again for a while and the light is off. Okay, so what else we have here? We have also the live. This is a energy detector, a live wire detector. Let me push here this cable. And how does this work? When you pass it over something that is electrical, he will start beeping. I don't know where is the sensor, so it's something around here. Yeah. When you approach the sensor, yeah, it's somewhere around the top. So you can use this to detect if a wire has current or not. You just come here and yeah, as you can see, it detects immediately if the wire has current. You can use this also in walls to detect wires with power. and you have this live function also. So right now is just missing to measure AC voltage. I have here a cable that is connected to the house mains. I will very carefully connect the two leads to it, and as you can see we have 234 volts. It should be between 230 and 240 volts here, so pretty on the spot. It's almost at 50 hertz. Yeah, almost. Yeah, everything is good. Okay, 50. Here we have it. So nice. Let's move on. Another feature that can be used is the live. With the live, instead, I don't know what is the purpose of this feature, to be honest. Maybe it has a good purpose that I don't know. Again, I will insert this very carefully in here, and it will say that it's live, only that. But for this we can also use the multimeter to see the voltage. So yeah. So for this test I will check the frequency. Depending on the frequency that you have, it will have a different resolution. Okay. It says it has more or less 0.1 reading plus 3 digits of error margin, and input sensitivity it should be 1.5 RMS. Okay, so what I will do now is, using my function generator that you should already have it on the screen, I will start by connecting this socket first and the common second one. Here we have it. Let's start by inputting here something like 10 hertz, yeah, something low, and turning the function generator on. Is detecting 9.998 hertz, 9, yeah, 1 digit, 2 digits to the side, 3 digits. It's between the error margin. So let's pump this to 1 kilohertz. So 9.99 hertz, 1 kilohertz. Let's try to increase this manually. Okay, 2, 3. I think the maximum of this is 10 megahertz. We are in the kilohertz zone yet, so I will crank this a bit. Yeah, 153 kilohertz. Okay, let's put this in 1 megahertz. Okay, 9999 kilohertz. It's 1 digit off. Let's move to 2 megahertz, 3 megahertz, 4, 5, all the way up to 7 megahertz, 8 megahertz, and it's not working anymore. Okay, let's see what he says here. This should be up to 10 megahertz, I believe. Here in the table says 10 megahertz, but it seems after 8 megahertz it will not work properly. Let's see. Yeah, I don't know. Let me lower this to 7 megahertz, 6999. You disconnected. I didn't press any button for a while. Okay, so it's in auto right now. And yeah, 8 megahertz. Let's move to 8. No, it will not go that far. Let's see if I crank this slowly. 7.5 megahertz up to 7.9, 7.8, 7.7 seems to be the maximum. Okay, but it will work. It has a frequency reader also. So from all of these symbols, I believe that we tested everything. So yeah. So let's wrap this up, and today let's start with the price. S1 has a price around 28 euros or around $30. That's a bit lower but pretty close to the GDVA GD128 or the Kawitz K601. That's the closer models from the competition that I found, so the price is in line with the products of the same range. I love these big numbers and the brightness of the screen. It gives you a very good readability, and also the response time is pretty good. The form factor is good for portability and the construction seems okay. The option of a silicone cover or something like that will be welcome, even if it's sold as an extra. In terms of precision, most of the readings are inside the tolerance range, so it's okay with me. But you should create your own opinion on what I just showed you. All things considered, in my opinion, this is a good tool for the price you pay. Well finished, precise and accessible. So if you are on the market for a multimeter, please remember that you have the affiliate link to buy this device on the description of this video, or you can use also the affiliate access links on the screen. Again, thank you for your help, it's really appreciated. If you learned something and this video was useful to you, please smack that like button, and if you haven't already, please subscribe and hit that bell to activate all notifications and be the first one to be notified whenever I upload a new video. That's it for today. I hope to see you in my next video. Until then, stay safe and cheers!